Hello everyone, welcome to my channel. Let's talk about our 13th chapter from organic chemistry, amines. So in this NCRT's audible series, I think it is helping you, but I'm not getting the results of my hard work. It takes time, yes, but guys, please support my channel. Please share it with your friends, subscribe it, and let's grow together. The chief commercial use of amines is an intermediate in the synthesis of medicines and fibers. So, what it is saying is the chief commercial use of amines is an intermediate in the synthesis of medicines and fibers. The chief commercial use of amines is an intermediate in the synthesis of medicines and fibers. So, these amines are used as intermediates for the synthesis of medicines and fibers. Let's talk about amines. Amines or amines constitute an important class of organic compounds derived by replacing one or more hydrogen atoms of ammonia molecule by alkyl or aryl groups. In nature, they occur among proteins, vitamins, alkaloids, and hormones. Synthetic examples include polymers, dyestuffs, and drugs. Two biologically active compounds, namely adrenaline and ephedrine, both containing secondary amino group, are used to increase blood pressure. So, amines constitute an important class of organic compounds derived by placing one or more hydrogen atoms of ammonia molecule by alkyl group or aryl group. In nature, they occur among proteins, vitamins, alkaloids, and hormones. And these vitamins are found. Synthetic examples include polymers, dyestuffs, and drugs. Polymers, dyestuffs, and drugs. Two biologically active compounds, namely adrenaline and ephedrine, both containing secondary amino group, are used to increase blood pressure. Two biologically active compounds, namely adrenaline and ephedrine, both containing secondary amino group, are used to increase blood pressure. What is used to increase blood pressure? Adrenaline and ephedrine. Ephedrine and adrenaline are both are what containing secondary amino group. They both are containing secondary amino group used to increase blood pressure. Novocaine, a synthetic amino compound, is used as an anesthetic in dentistry. Benadryl, a well-known antihistamine drug, also contains tertiary amino group. So these are the names of the drugs. Like adrenaline and ephedrine, both are containing secondary amino group, and these compounds are used to increase blood pressure. Novocaine is a synthetic amino group drug, amino group containing compound. It is used as an anesthetic in dentistry. Benadryl, a well-known antihistamine drug, also contains tertiary amino group. So Benadryl. So you have heard the name Benadryl, Novocaine, epinephrine, adrenaline, ephedrine. These are amino group containing. Adrenaline contains secondary amino group, whereas Benadryl contains tertiary amino group. Quaternary ammonium salts are used as surfactants. Quaternary ammonium salts are used as surfactants. Quaternary ammonium salts are used as surfactants. Diazonium salts are intermediates in the preparation of a variety of aromatic compounds, including dyes. In this unit, you will learn how amines and diazonium salts. About amines and diazonium salts. So Novocaine is used as anesthetic in dentistry. Adrenaline and ephedrine, they are used as secondary. They are the secondary amino group of blood. They increase blood pressure. And Benadryl is a well-known antihistamine drug. It contains tertiary amino group. Quaternary ammonium salts are used as surfactants. Diazonium salts are intermediates in producing in the preparation of variety of aromatic compounds like dyes. In this unit, you will learn about amines and diazonium salts. So today we'll complete amines, inshallah. Amines can be considered as derivatives of ammonia. What are amines? Amines are derivative of ammonia. As we have said in the first line itself, these are derived by replacing one or more hydrogen atoms of ammonia molecule by alkyl or aryl groups or group. Amines can be considered as derivatives of ammonia obtained by replacement of one, two, or all the three hydrogen atoms of bi-alkyl or aryl groups. For example, CH3NH2. This is primary. Only one hydrogen is replaced by CH3 group. C6H5NH2. CH3NH CH3 secondary amine group. Secondary amine. CH3N CH3 tertiary amine. Structure of amines. Like ammonia, nitrogen atom of amines is trivalent and carries an unshared pair of electrons. Nitrogen pair of electrons, unshared pair of electrons, it's trivalent. Nitrogen orbitals in amines are therefore sp3 hybridized and the geometry of amines is pyramidal. Each of the three sp3 hybridized orbitals of nitrogen overlap with orbitals of hydrogen or carbon depending upon the composition of the amines. The fourth orbital of nitrogen in all amines contain an unshared pair of electrons. The fourth orbital of nitrogen in all amines contains an unshared pair of electrons. The fourth orbital of nitrogen in all amines contains an unshared pair of electrons. The fourth orbital of nitrogen in all amines contains an unpaired share of electrons. Due to the presence of unshared pair of electrons, the angle of CNE, where E is carbon or hydrogen. So carbon, nitrogen, carbon or hydrogen is less than 109.5 degree. For instance, it is 108 degrees in case of trimethylamine as shown in figure. 108 degrees for trimethylamide. 108 degrees. So due to the presence of unshared pair of electron, the angle between carbon, nitrogen, carbon and hydrogen is less than 109.5 degrees, that is 108 degrees in case of trimethylamine. You can see in the figure. Classification. Amines are classified as primary. Primary means 1 degree. Now talking about classification, you can see trimethylamine is having 108 degree angle because it is having unshared pair of electron. Shape is pyramidal. Classification. Amines are primary. Amines are classified as primary. Amides are classified as primary, secondary and tertiary depending upon the number of hydrogen atoms replaced by alkyl or aryl groups in ammonia molecule. If one hydrogen atom of ammonia is replaced by R or AR, means alkyl or aryl group, we get RNH2 or ARNH2, a primary amine. If two hydrogen atoms of ammonia or one hydrogen atom of RNH2 are replaced by another alkyl or aryl group, then we will get secondary amine. If two hydrogen atoms of ammonia one hydrogen atom of RNH2 are replaced by another alkyl or aryl group, what would you get? We'll get secondary amine. You get RNHR- secondary amine. The second alkyl or aryl group may be same or different. Replacement of another hydrogen atom of alkyl or aryl group leads to the formation of tertiary amine. Amines are said to be simple when all the alkyl or aryl groups are the same. They are called simple, and mixed when they are different. So primary, you can see primary amine. So first ammonia is there. Its one hydrogen is replaced by alkyl group. It is called primary amine. Then one more hydrogen from ammonia is replaced, means two hydrogens are replaced by alkyl group, or you can say one hydrogen is replaced from primary amine. So you get secondary amine. What did I say? From ammonia, two hydrogen atoms are replaced by alkyl group. or you can say one hydrogen atom is replaced by alkyl group in primary amine, then we get secondary amine. Similarly, all the three hydrogen atoms are replaced from ammonia by alkyl group, that is tertiary, or you can say another hydrogen from secondary amine is replaced by alkyl group, it is tertiary. If all the alkyl groups are same, it is called simple, and if all the alkyl groups are different, they are called mixed. When they are different, they are called mixed. When they are same, they are called simple. Now, talking about nomenclature, very important. In common system, an aliphatic amine is named by prefixing alkyl group to amine, that is alkyl amine. In common system, an aliphatic amine is named by prefixing alkyl group to amine, that is alkyl amine, as one word. Example, methyl amine in secondary and tertiary amines. Common system, an aliphatic amine is named by prefixing alkyl group to amine, that is alkyl amine, as one word. Example, methyl amine. In secondary and tertiary amines, when two or more groups are the same, the prefix di or tri is appended before the name of alkyl group. In IUPAC system, primary amines are named as alkanamines. The name is derived by replacement of E of alkane by the word amine, alkanamine. Alkanamine. For example, CH3NH2 is named as methanamine, or common name methylamine. In common name alkylamine, in IUPAC alkanamine by the word amine. For example, CH3NH2 is named as methanamine. In case more than one amino group is present at different positions at the parent chain, the positions are specified by giving numbers to the carbon atoms bearing NH2 groups, and suitable prefix such as di, tri, etc. is attached to the letter to the amine. The letter E of the suffix of the hydrocarbon part is retained. For example, NH2 CH2 CH2 NH2 is named as ethane 1,2 diamine. In case more than one amino group is present at different positions in the parent chain, more than one amino group is present at different positions in the parent chain, the positions are specified by giving numbers to the carbon atoms bearing NH2 group. Its suitable prefix such as di, tri, etc. is attached to the amine. The letter E of the suffix of the hydrocarbon part is retained. For example, H2N CH2 CH2 NH2 is named as ethane 1,2 diamine. To name secondary and tertiary amines, we use locant N to designate substituents attached to a nitrogen atom. For example, CH3NH CH2 CH3 is named as N-methylethanamine, and CH3 CH2 taken thrice N is named as N, N diethylethanamine, N, N diethylethanamine. For more examples are given in table 13.1. In aryl amines, NH2 group is directly attached to the benzene ring. C6H5NH2 is the simplest example of aryl amine. In common system, it is known as aniline. Very important, aniline. Common system, CH6H5NH2. Benzene ring is attached with NH2 group. It is also an accepted IUPAC name. While naming aryl amines according to IUPAC system, suffix E of arene is replaced by amine. Thus, the IUPAC name of IUPAC system. Thus, in IUPAC system, C6H5NH2 is named as benzenamine. Common and IUPAC names of some alkyl amines and aryl amines are given. See for primary amines, alkylamine common system, alkanamine IUPAC system. For example, CH3NH2 is named as methanamine. Common name methylamine. In case more than one amino group is present at different positions in the parent chain. In case more than one amino group is present at different positions. See, if more than one amino group are there, then in the parent chain their positions are specified by giving numbers to each carbon atom bearing H2 group, and suitable prefix such as di, tri, etc. is attached to the amine. The letter E of the suffix of the hydrocarbon part is retained. For example, NH2 CH2 CH2 NH2 is named as ethane 1,2 diamine. So this is important. Ethane 1,2 diamine. Suffix E of the alkane is retained. Amine CH3 CH2 NH2. Ethane amine. Common name ethylamine. CH3 CH2 CH2 NH2. And propylamine. Propaneamine. Propane 1 amine. Isopropylamine CH3 CH NH2 CH3. Isopropylamine. Propan 2 amine. CH3 NH CH2 CH3. Ethyl methanamine. Ethyl methylamine. In IUPAC system, how can you say N-methyl ethanamine. CH3 NCH3 CH3. This is called trimethylamine. N, N dimethyl methanamine. C6H5N C2H5N C2H5 CH2 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 CH3. You can name the long chain as 1 2 3 4. You can say N, N. In IUPAC system, you can give a systematic name like N, N diethyl butanamine. Butan 1 amine. N, N diethyl butan 1 amine. N, N diethyl butylamine. N diethyl butylamine. N, N diethyl butylamine. Allylamine 1 2 3. NH2 CH2 CH double bond CH2 is called allylamine, or you can say prop 2 in 1 amine. NH2 C2 CH2 whole 6 NH2. Hexamethylene diamine. You can say hexane 1,6 diamine. NH2 C6H5 aniline. Or you can say benzanamine. NH2 C6H5 CH3 orthotolidine. Or you can say 2-methyl aniline. Para-bromoaniline. You can say 4-bromo-benzanamine or 4-bromoaniline. And CH3 taken twice on benzene ring. So you can say N, N dimethyl aniline or N, N dimethyl benzanamine. So these were the common names. Aniline is very important name, and you can remember one more name, tolidine, orthotolidine. NH2 group on benzene ring and CH3 at ortho position to aniline, to amine group, right? So 2-methyl aniline. Now let's see, classify the following amines as primary, secondary and tertiary. So first one, so you can check this, you can check the table, it's very important one. So orthotolidine is very important. Now let's talk about the questions given. Classify the following amines as primary, secondary or tertiary. So the first one is primary. See, if the amine group attached to this groups are having 2 hydrogens, it is primary. If it is having 1, secondary. No hydrogens with nitrogen, then it is tertiary. First one primary, second one tertiary, third one primary, fourth one secondary. Write structures of different isomeric amines corresponding to the molecular formula C4H11N. Write the IUPAC names for all the isomers. Write type of isomerism is exhibited by different pairs of amines. We'll do this later. Now let's talk about preparation of amines. Very important. Amines are prepared by the following methods. First method is reduction of nitro compounds. Nitro compounds are reduced to amines by passing hydrogen gas. So how nitro compounds are reduced to amines? You can see, we want NH2 group on benzene ring, then you will get aniline, or or benzenamine. So take nitro compounds like nitrobenzene. So it can be reduced to amines. The two oxygens can be replaced by hydrogen. So removal of oxygen is called reduction, or addition of hydrogen is called reduction. So nitro compounds are reduced to amines by passing hydrogen gas in the presence of finely divided nickel. But these oxygens will not be ready to leave. So what you have to do, you have to take finely divided nickel, palladium or platinum, finely divided nickel, platinum, palladium, and also by reduction with metals in acidic medium. You can do, or you can take metals and acidic medium. So nitroalkanes can be also be similarly reduced to the corresponding alkanamines. So take nitrobenzene and let it undergo reduction by passing hydrogen gas in the presence of finely divided nickel, palladium or platinum. Ethanol also you can take, and you will get aniline. And take nitrobenzene and you can take metals in acidic medium like SN plus HCl, tin plus HCl or Fe plus HCl. You can take tin or Fe, they are good reducing agents. They will give hydrogen readily, and that will be replacing the oxygen atoms, and hence nitrobenzene get reduced to benzenamine or aniline. Reduction with iron, scrap and hydrochloric acid is preferred because FeCl2 formed gets hydrolyzed to release hydrochloric acid during the reaction. So reduction with iron, scarp and hydrogen chloride is preferred because if you take directly FeCl2, so if you take iron, scarp and hydrogen chloride as reduction reducing agent is preferred because it is preferred. Iron scarp with hydrogen chloride is preferred because FeCl2 formed gets hydrolyzed to release hydrochloric acid during the reaction. Thus only a small amount of hydrochloric acid is required to initiate the reaction. Small amount of hydrochloric acid is required, so iron, scarp and hydrochloric acid is preferred because it will form FeCl2 that will get hydrolyzed, release hydrogen chloride gas. Chloride acid, hydrogen chloric acid, HCl during the reaction. Thus only a small amount of hydrochloric acid is required to initiate the reaction. Now we'll read ammonolysis of alkyl halide. You have read in unit 10 class 12 that the carbon halogen bond in alkyl or benzyl halides can be easily cleaved by a nucleophile. Nucleophile means electron donor. Hence an alkyl or benzyl halide on reaction with an ethanolic solution of ammonia undergoes nucleophilic substitution reaction in which the halogen atom is replaced by an amino NH2 group. This process of cleavage of the CX bond by ammonia molecule is known as ammonolysis. The reaction is carried out in a sealed tube at 373 Kelvin. The primary amine thus obtained behaves as a nucleophile. We'll discuss the preparations in next.